All right, welcome back, everybody. So this is Admin of Code Day 2. We're going to be doing it in Swift and Xcode, and I'm going to be talking you through my thought process as we solve these problems. Like last time, this is a race. So I'm not going to describe my process very much at the beginning. I'll describe that at the end. I'll do my best, though, to tell you my thinking. All right, first things first. This is where we left off on day 1. So what we're going to do to make things cleaner is we're going to introduce a new file. And this is how I like to organize my code when I'm doing admin of code. I'll create a new file, and I will cut all of this. I don't need the hello world anymore. I will put it in a function called day1. Boom. That's what I like to do. And so then I can do day1 right there, just like that. And when I run it, you'll see build succeeds. Boom. There we go. So answer to day part 1, part 2 of day 1. All right. So since I don't need it to solve day 1 anymore, I'm going to introduce a new file called day 2, and then we're going to pop up with a question. Okay. Func day 2. Okay, let's go read the question. Your flight departs in a few days from the coastal airport. The easiest way down to the coast from here is via Toboggan. That's a sled, I think. There's Toboggan rental shop. Something's wrong with our computers. We can't log in. Their password database seems to be a little corrupted. Some of the passwords wouldn't have been allowed by the official Toboggan corporate policy. Okay, to try to debug the problem, they have created a list, your puzzle input, of passwords. Okay, so it's an array of strings, I'm guessing, according to the corrupted database and the corporate policy when that password was set. Okay, so for example, we have this 13 A B C D E. Each line gives the password policy and then the password. The password policy indicates the lowest and highest number of times a given letter must appear in the password to be valid. That's a must appear. For example, 1 through 3A means that the password must contain A at least 1 time and at most 3 times. In the above example, 2 passwords are valid. The middle password, CDEFG, is not. It contains no instances of B. Okay, easy enough. But needs at least 1. Yeah. The first and third passwords are valid. They contain 1 A or 9 C's. Wait, what? First and third passwords are valid. They contain 1 A or 9 C's. Got it. Both within the limits of their respective policies. How many passwords are valid according to their policies? Okay, so we're going to have a list of, I'm going to assume these are strings, and then we're going to have to parse the strings. So we're going to have to, we're going to have an input as well, day 2 input, because this is global, equals 123, 123. Okay, the other thing I'm probably going to want is a password struct that is going to be like, let's see, letter, which is going to be a character. I hate messing with strings in Swift, but we'll see. Character might be fine. We also need minimum count, and we need a max count, and then we have the password, which is a string. Okay, so what we're going to do is we're going to take the input that they give us and we're going to turn it into a whole bunch of these password objects, an array of password objects. Let's get your puzzle input. Yeah, okay, same format that I kind of expected. Let's paste it in there. Whew, that's a lot of passwords. Okay, so the first thing that we want to do is we want to say, let's do this. We're gonna start by saying that passwords equals day to input.split on the new line character. So it's going to give us each individual row, and then we're going to map it to a password that that takes in a string as an initializer. And then we're going to say init with string. And so then what we can do, so my first thought here is like, let's split the string on the white space. So let's do components equals string.split on white space. And then we're going to do min equals comps.split on the dash character. So that will take this first component and split on the dash. And then, this is min max. And then we're going to say let self.minimum equals, I'm going to change this to min because I'm probably going to be typing it a lot, and I don't care about code readability as much in these kind of competitions. Okay, so min max sub 0 is going to be an int, and self.max equals int min max sub 1. Okay, and then the second thing is a W. Okay, so self.letter equals comps sub 1. So it's the 1th index, the first index. It doesn't like that it's a substring. Can I just do that, or do I have to initialize it as a string? I don't remember. Nope, I gotta initialize it as a string. Like that. Does that make you happy? This is why I hate messing with strings, is I know that the substring type makes it type safe, but it's very annoying to work with. Substring, is that what it wants? Is it failable? Like, what's the issue here? Is ambiguous without more context. What on earth? Okay, so whenever you have something big and nasty like this, the best way to debug it is to break it into its parts, to understand that. It does not understand that. Does it understand that? It does not understand that. A subsequence. So annoying. Okay. I don't know if this will let us turn these subsequences into strings. See, this is like, you have to. Okay, so now it's strings. So now this is a string of subsequences, which we're also going to. See, this is like, if you're watching this and you know a better way to do this, please tell me, because this is going to annoy me the entire time. Oh, what did I mess this up here? This is supposed to be sub-0. Keeping that first part and then mapping those as strings, I think, is what I'm actually after. Yep, so I'll have 2 to 6 as a string, and then I can do min-max sub-0. Boop. Boop. I think that's right. It's happy. Okay. Okay, self.letter is comps sub 1. See, and this is another thing. I wish there was a way that I could just get the first character again. Why would I ever split screens from a day job? And then self.password equals min max sub 2. Okay, so let's try Oh, because this is, yeah, turn it into a string for me. Okay. And then let's make sure that we just have our parsing logic right here. It shouldn't crash. That's the goal. Did I update? I did not update main to call day 2. Day 2. Failed. Index out of range. Comps 3. Oh, min max. Yeah. Okay, perfect. So we got it all parsed out. Okay, so let's go back over to our requirements here. So the requirements are this letter has to appear in this many times. Okay. So what we're going to do is we're going to go through each password, and we're supposed to keep track of how many are valid, or how many passwords are valid according to the policies. So we're going to say valid equals 0 for password in passwords. We're going to go through all of them. And then we're going to say if password is valid plus equals 1, and then print valid. And then what we're going to do is we're going to create a function down here. Function is valid bool. And then what we can say is, well, the requirements are, we want to find out how many times this letter occurs in the password. So what I think that we can do is let's do letters equals, let's turn it into an array because it's just easier to index into an array of characters. And then we're going to say for letter in letters, if letter equals self.letter, and we're going to say var total equals 0. We're going to count them plus equals 1. Okay, so then we're going to, the return is if total is greater than or equal to self.min, and total is less than or equal to self.max. I'm going to guess that's right, yeah, because 9 is the max and 1 is the min. Okay, let's try it. Let's run this thing. 536. Let's try it. 536. Submit. 1 gold star. Continue to part 2. Well, it appears validates correctly. Suddenly realized you just accidentally explained the password policy rule. The official toboggan corporate policy works a little differently. Each policy actually describes 2 positions in the password, where 1 means the first character, 2 means the second character, and so on. Be careful. Okay, so interesting. Have no concept of index 0. That's dumb. Must contain the given letter. Other occurrences of the letter are irrelevant for the purposes of policy enforcement. To give an example, 1-3 is valid. Position 1 contains A and 3 does not. 1-3 is invalid. Neither position 1 nor 3 contains a B. Is invalid. Both positions 2 and position 9 contain. Okay. So be careful. 2 positions where 1 means the first character, 2 means the second character, and so on. Exactly one of these positions. Does Swift have an XOR? I guess it does. Maybe it doesn't. Oh, it exists for ints. We can try ints. Let's try it. Is valid 2. So what we're going to do is let first position equals, we're gonna need this again. Okay, first position is letters, self.min, and second position equals letters self.max, and then we're gonna say, okay, and then we don't actually want the letter. We want to know if it equals self.letter. We know if it equals self.letter, and if it does, then that's a 1, and if it doesn't, that's a 0. 1, 0. Return first position exclusive or second position. Does that work? Does not equal 0. Okay, let's see if that works. So what we're going to do is we're going to do, so this is day 1, day 2. We're basically going to copy this, except for we want the, we're going to reset valid to be 0. Password is valid 2. Okay, let's try it. Doesn't like that. Oh, dumb, because they don't have a 0 with index, so you have to subtract 1 from it to normalize the data. 558? I mean, I don't know. It sounds reasonable, so let's try it. If not, I'll switch it from the exclusive or. That worked. Cool. Completed day 2. Return to your calendar. Okay, so let's talk about this really quick. So as I was reading the problem, let's go back to the problem. Give you an idea of how I'm thinking about problem solving. So when I see this, I know enough about these problems that it's always going to be a string of some kind that you need to manipulate. Your input is always going to end up being some sort of string because of just how it's easy enough to read it in that way. So I see, okay, this is going to be a string. And then when they start describing what this means, I immediately know that, like, okay, we need to break apart this string and make sense of its parts. So that's why the very first 2 things I did were create this giant input string with this multi-line string, and then split it apart into each line. Now, how do you eat an elephant 1 bite at a time? And this is my 1 byte at a time is taking 1 line. So I knew that 1 line represents a single password, so I thought, okay, since I'm going to have this idea of a password and I'm going to be doing operations on it, I want each of these pieces to be stored in some way so I can manipulate it. Just is cleaner to keep track of rather than like splitting it into pieces inside a loop and then trying to do something with it there. So that I was like, okay, that all of that is adding up to say, okay, well, we need an initializer for password that takes this style of a string and splits it up into the components, pulls out the min and the max. In fact, let me even show you at runtime if you're sort of new, so you can kind of understand what this even looks like. So comps, what we've done here is, again, we've already split it into a single line, and so we're splitting the components out of this single line. And so you can see right here, it's split out to 2.6, W colon, and then WK. Okay, and if you look at, well, let's go down here. If you look at this, that makes sense, right? Because we're splitting on the new line, and then we're splitting on each of the spaces right here. And then min-max is taking the first component, the one at the 0th index, which is this, and splitting it based on the dash character. So that separates the 2 from the 6. Yeah, so here you go. Now, if I was going to do this for like a real production app, I would actually probably follow something closer to the Codeable protocol, where this would be a failable initializer or initializer that can throw. And then I would also, I would be much more, I'd probably just read 1 character at a time, because like, it's not a ton, right? But you know, if I'm going to have millions of these, like initializing strings and doing all these split operations and stuff like that, like they do cost something. And so I would probably actually just do the work of reading them 1 character at a time. This just is like, okay, there's stuff built into Swift to make this so my brain doesn't have to work very hard. And when I'm in a race, I'm trying to minimize how hard my brain works. Okay, so running through that, that's how you get the pieces out of each individual line from the password. Now the is valid, that part is pretty easy at that point. They literally just describe to you what they want. So 1 to 3 A's, which means greater than or equal to 1, less than or equal to 3. It's very important. Notice when you're doing these kind of things, Advent of Code's good. They give you examples. So they'll say 1 to 3 works because it's 1. So they actually indicate that like this is an inclusive or, that it can be 1. Because it could, like, if it wasn't clear, it could be like, oh, it has to be greater than 1, right? And same thing, they give you the extreme here. It has to be less than or equal to 9. In this case, it's equal to 9. So they clarify whether it's an inclusive or an exclusive or. Okay, so that's pretty easy. You're just going through and you're saying like, okay, let's count how many letters, how many times the letter we've been told appears in the password, and then we make sure it's greater than the min, less than the max. Now for is valid 2, in case you didn't catch on to what I was doing, the reason why I used integers here instead of booleans is because I wanted to use the exclusive or operator. I've never actually had a use for it, I don't think, in Swift. I've used it in other languages, but I don't think I've ever used it in Swift. So what it does is it takes a binary representation of 2 integers and it compares them, and at each digit of the binary, so let me show you what this looks like. So you have 1, 0, and well, in this case it's actually 0, 1. So this is 1 in binary, this is 0 in binary, and it goes by each of these positions and it says, okay, 1 and only one of these can be a 1, and so in this case 1 and only one of these is a 1, and so it says, okay, well the answer is 1. Now where this would fail is if it was like this. So that would say, oh, you know, this is exclusive or, that means that you can't have 2 of them that are 1. It's 1 and only one of them can be 1. That's why it's exclusive. So the other thing that would come out to be 0 if they're both 0, right? Because neither of them are 0, or neither of them are 1. And this works for integers. So like if I was doing this is 2, right? Yeah, 2. And then you exclusive or, the result would be 2. So the reason why this works, because I'm using it in this limited situation, and you saw when I pulled up the Stack Overflow that somebody showed an extension that you could add to Boolean to add an exclusive or operator. But this was nice because this is like, okay, like in this little self-contained area here, I can use a 1 and a 0 to represent true and false, and then I can exclusive or them, which means exclusive or 1 and only one of them can be equal to 1, and it turns out that that's exactly what they want, right? You're looking at this, in this case, the 2nd and the 6th character, and 1 and only one of them can be a W. Okay, so that's my solution to Advent of Code day 1. Not as many mistakes and rewrites. I'm sure there's plenty of efficiencies, and again, like if you're better with string manipulation and you know how to do some of these things, let me know. I'd love to hear it. I've already learned something from some fellow engineers that were watching my previous video. They taught me how to do labeled breaks, which is pretty awesome. So I'll be using that in a future video once I have a use case for another break statement. All right, well that's all for this episode. Make sure that you like and subscribe. Helps the channel grow, obviously. And if you want to see the rest of the Advent of Code breakdown, then obviously you'll want to subscribe so you can see the rest of these. All right, catch you on the next one.